Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at template classes in C++. Template classes allow you to design classes that work with types of variables that the user can specify. So as an example of a template class, we could think of, for example, vector. When you create a vector, you specify the type. It could be a primitive type or a class type that the vector actually stores. So we could have string in there or whatever, and then we add the variable name in there. So vector is a template class, and that's why vector is a member of the standard template library. Template classes are not often useful in C++, but when they are useful, they can be really useful. So they are worth knowing about, and they're not really that complicated. If we create a normal sort of class here, let's call this class test. To turn this into a template class, all we have to do is write template, and we have diamond brackets here, as we do when we're supplying the type to vector, for example. And in there we type class, and now we need a letter to stand for the type that the user can specify. So you can type a whole sort of thing in there, like you could call it thing or whatever, but it's quite common just to use single letters for this purpose, because you can't really, you can't really say what they are, because the user has to specify what class they actually are. So T is a kind of traditional letter to use for just a kind of generic template type that the user is going to specify. And once we've done that, we can use this in our class as though it was some actually defined type, like string or int or whatever. So we can't really call any methods on it, because we don't know what methods it's going to have. But we could use various operators on it, and we have to assume that those operators have been implemented correctly in the type that the user passes in. So let's just take a look at how this works. So once we've got this, we could, for example, we could define a variable of that type in the class. Let's have a private section. We could have a T, I'll just call it object or obj or something like that. We could use it as the return type or the parameters to methods. So we could say public. Let's have a constructor here. Let's say test and T. We'll call that obj, and we'll use that to initialize the variable here. So you don't have to use any of the particular things that I'm showing you. These are just things that you can do with it if you want. So let's say here this arrow obj equals obj. So we're just setting this equal to the one that we pass in, whatever it is. We could create a method now. Let's say void print. So we want this to display the object. So if we assume that these objects have got to have the stream insertion operator implemented, then we could say cout and output the object that we use to initialize the instance variable here. So this could take T as a parameter type. It could return T. It could define local variables of type T. You can do anything with T, just like it's a real class. But because you don't know what methods it's going to have, you can't use them. You could get into interrogating this object, the objects that are actually kind of the type defined by the user, and figuring out what methods they have and calling only those methods. But that's pretty bad practice, really. If you if you define a template type, you really should not get into inquiring what type it is and calling specific methods on it, because that kind of breaks the whole object-oriented idea of defining objects in such a way that you can use them without interrogating the object type. So it's not good to have ifs in here. Say if it's this type, do this. If it's that type, do that. You could do that, but it's not really advisable. So how do we use this class? Well, just like we use vector. So we say test, and then after the type here, part of the type is the template type definition. So we have to specify after the class name what type of object it's going to work with. Let's say, for example, string. And then let's create a class I'll call it test1. Then we can say, well, we need to pass that to the constructor. We've got a constructor that takes a parameter, and we've said it's going to be of type string. That's T is going to be string now. So let's pass in hello here, that's a string, and then let's call test1.print. And run this, and it works just fine. So this is going to be useful for something like if you're implementing something that stores other objects, or you might find other uses for it. The most common thing probably is to implement a class that somehow stores objects of a type that you specify, but of course there are other possibilities here. To practice this, I'd recommend certainly typing out this code, getting it to work for yourself, and try using something other than the stream insertion operator. Think what other objects you might reasonably expect to be defined on a generic type that you're using here, and see if you can do something else with this, as well as perhaps using the stream insertion operator. You'll recall from maps that if you use your own object as the key in a map, it expects you to define the less than operator for that class that you're using it with. So it's not uncommon to make certain assumptions when you're writing this kind of a class about what objects what operators this class T will define. You know, you might have to make some assumptions, and then of course the code won't work if the user uses it with the wrong type of class and doesn't implement the operators that you expect. But think about creating some class that uses some other operator with your generic objects. You can pass them into a function. You could have t_obj here. You could use them like this as well, like I have done. Anything that springs to mind, really. Just have a go and see what you can think of doing with that. And another thing to try is that you can also have multiple template types here. So I could type class, let's call it K or something. Often K and V are used for the types of keys and values in maps. And then if I define it like this, of course we have to supply a separate type. When we actually use it, we have to supply the second type as well, because we've got two types to define here when we actually create objects from the class. And then we could use K in here in some way as well. So it's worth trying to think of putting K to some use. Inevitably at this stage, if you try this code, it's going to be a bit artificial, because you might not have any real idea what to do with this, but if you think of something that at least illustrates the concept, it will help you practice this to get that working. Okay, so that's it for this tutorial. We'll look at template functions in the next tutorial, and until next time, happy coding.